Any part of the presentation. Is it in the presentation, like the link, that we can click on it? Okay, there's no one suggested before.
So
Well,
then we will have to move the laptop second.
no, I mean, if I think you can just, if it's a link that we can click on, so try to find the presentation. If it's a link we can click on, and it should be able to just display.
This is all I have, Professor.
Good afternoon. If you're in the room for the Sidrops working group, you're in the right room. If you think you're at something else, you should leave now or stay, be quiet and listen. You might learn something. I know I will. If somebody in the back could please close the door, that would be great. We'll be getting started in a moment or two. We're just sorting out some slide problems. Ooh, the mic works now. Yes, sir.
This looks like an old version.
Oh, I uploaded a new version and emailed it to you, so you'll have it in email.
It's also the IETF.
Yeah. It's because I uploaded it.
One sec.
Yeah.
What are you? We have time, right?
Yeah. It's on the application. That's good. Should be right. Yeah. That's the learning validator one.
You're right. Go to the very end. Okay, yeah, this is the stuff. It looks like this is it. Okay, we'll just leave this that person. That does not include the link to the presentation.
Yeah, just present that. I think you can hit the little presenty button. That. Oh no, that'll download your computer.
I'm not sure. Did they get you next?
What's that? Should, I don't know.
The other thing we can do is have them just bring their laptop in and
Do you
present
want to
it.
just present it from your laptop?
You want to present it from your laptop? Can you give me your laptop? That way.
It's fine. We can just flip back.
Sam. What, do you have this? Yes.
It's presenting. Okay. Just put our slides up. While we're getting last things done, is there someone who wants to be a Jabber scribe? We can't go until we get a Jabber scribe and a notes taker. Maybe Jabber scribe? Jared. Joel says he'll do the Jabber scribe. Notes? Jared wants to do notes? Tim? Okay, terrific. So we have both of those. That's not helpful. Jared says he'll do notes? Okay, thank you. Excellent. Okay. All right, as I said earlier, Come on, computer. This is the Sidrops working group at IETF 99. I'm Chris, that's Kayur. And we have a presenter, Amir, after I'm done, I think. We have a notes taker, Jared, a Jabber scribe, Joel. Unless I got those backwards. Next slide, please. Notewell, tiny, tiny font. You can view it on the website. It hasn't changed since last time, I hope, because that's where I copied it from. Next. It changed? Great, I'll change the slide later. And T, you already know that it changed, so you didn't have to read it. Okay, so the agenda's relatively long, relatively full this time. So we don't have a lot of spare time. So in case anybody wants to add anything else, no, great. We have the following set of presentations. Amir will be up next. But in the agenda bashing thing, we'll also cover current documents. Skip. The 4 documents on the tools page for us, they're still the same 4 documents we've had before. There's some progress for route server RPKI Lite, I believe. I think those folks are in the room and had something to say. They could hop up and say it if they like. 3, 2, 1. I think they have some updates they're working on since they're not coming to the mic. And then they'd like to ask for working group last call. So maybe in 3 or 4 weeks, we'll have a working group last call message for RPKI Lite or route server RPKI Lite. If you haven't read the draft, you should probably go read it now or after other presentations, sort of today, and send comments along to the authors. Tree validation says it's coming up for expiration, but I believe that Tim is planning to present today about it, so we'll get some update on that as well. That's where we are. Next. Now it's Amir's turn. Oh, wait.
Oh, sorry. On BGP exec rollover, Brian
Yes.
Live, Cisco. Last meeting, you asked for people to review it, and Randy did. Thank you very much. Apparently, nobody else did. We're kind of waiting on approval to go forward on that.
Okay, so you would like to try to work your blast call it?
If the chairs feel there's been enough review, sure.
Sounds great
There
to
was
me.
quite a bit of review insider. So.
Yeah, yeah.
Oh, no. Okay. Apparently, I missed another set of comments. So
You have a presentation?
from Sidrops. Thanks.
You are on the agenda.
Sriram list. So I gave a very extensive set of comments during the working group last call. So I was surprised that that was not noted, but it seems you haven't seen it yet. But,
Oh, so I think maybe you mean insider.
yeah,
Yeah, that's fine.
no. Oh, I haven't seen those response.
Okay, we can work that on the list. All right, you're up. We're supposed to tell you stay in the pink box because you're being recorded by the thing over there. Okay, terrific.
Do this like this.
That, or you can put it in there, however you feel comfortable. Please, by the way, speak into the mic. Don't look away and speak because it doesn't work.
Okay, let's maybe I'll hold it like this. Okay. Yeah, but this I'm not used to this kind of stuff. Anyway, we'll manage. Where is the presentation?
Coming?
Coming. Okay. Well, until it's coming, this is some research work we've been doing, and we are working now on. Just a moment. No.
We're all in trouble now.
No, nothing special. Just do it again. I think it will be.
Aha.
Sorry for stepping out of the box. Okay, so it's RPKI deployment, status, challenges, and the learning validator, which is one of the things we are trying to do to help RPKI deployment. Okay, this is joint work, as you can see, with a list of many people down here. Yossi Gilad, Thomas Salvek, which is here, Yafim Kazak, which is here, Refik Peretz, which is here, Michael Shapiro, and Chaya Schulman, which are not here. Okay, so I'll talk very briefly about RPKI. Well, you all know it, so I'll just skip over that. And then about ROA adoption, the trend, wrong ROAs, which are, in our opinion, a big problem, especially for validation. So we'll talk about that, the causes of that, the damages of that, and then the ROV adoption status and the challenges facing that, which are the kind of things we are trying to solve. The impact of partial ROV adoption, as you will see, adoption of ROV is almost non-existent. So we'll talk, well, if we had a slightly better adoption, would it help? Short answer, not so much. We need significant adoption. So what do we do? And we'll talk about directions that we are pursuing for improving the deployment of all that, which is rawalert.org, a simple mechanism for fixing or identifying incorrect RAWs. And then the smart validator, which is our main focus, which is a mechanism for improving the validator or an improved version of the validator. And that's a prototype implementation we have. We are hopefully moving soon to prototype experiments with the prototype deployments and so on. And we are looking for more partners to discuss this with. So I hope some of you will be interested in that code. Okay. Hopefully we'll do a demo, probably not actually, but we'll see if we have time. Okay, you all know about RPKI, I don't need to explain about that. Essentially, it's a linkage between the IP prefix and the origin, and possibly the max length for that. And the main point is that for RPKI to work against route hijacking, domains must do route origin validation, ROV. That is, they should drop BGP announcements which conflict with the ROA. Without that, just issuing ROAs is not actually very interesting. The whole question is, would the service providers, would they actually throw away BGP announcements which contradict the published valid ROAs? Okay, so that's really our focus. If we look at ROA adoption history, there is a progress. As you see in the green line, there is progress. There are more and more ROAs being issued. Of course, there's also progress in the internet in general. As you see in the yellow line, the internet itself is growing, but ROAs are growing in a slightly higher pace than the general internet, so that's good. However, the problem is the red line. The red line are the errors. And why this line of errors is kind of erratic and it's going, jumping up and down and so on, it is pretty consistently 10%. About 10% of the issued ROAs are incorrect. 10% errors is a lot, and that's really can be a problem, okay? And now, what happens if we have an incorrect, such a mistake and wrong ROA, and we do ROV like we're supposed to do, then we drop correct BGP announcements. That is, we are going to lose some good traffic. How many domains then are actually doing it, are doing the ROV? And the answer is, as one would expect, if that's a situation, very, very few, okay? So why would we even have wrong ROAs? So this is a real-life example of France Telecom. I don't know if maybe recently it was fixed, but until quite recently it was not fixed, although we did ask them to fix it. And they have this pretty large block prefix, okay, /15 prefix, out of which they have some customers, with /24 and so on, like many providers do. Now, France Telecom are good guys. They are issued their own ROAs. The only problem is, as a provider, they have not made sure that their customers will also issue ROAs. As a result, if my internet service provider will be doing ROV, will be filtering BGP announcements which contradict this ROA, then my supermarket chain using it will not be able to contact the website or domain, and I will not get any yogurt, and I love yogurt. Okay, so this is really a problem, okay? Well, you may not care about yogurts, but I do. So this is really a problem. And therefore, we are all here together to make sure that I get a steady supply of yogurts, okay? Okay. So the question is, how many of the service providers do it? I mean, what is the risk for me of not getting yogurt? And for that, it's not trivial to measure it. Initially, we did this very indirect, imprecise, but very easy to do experiment, which is we just look at the different collector of BGP announcement, where all the monitors that have public availability that we could check, and we checked which of them get all of these incorrect ROAs. Because if you get one of these, incorrect BGP announcement, because if you get, it's not really incorrect BGP announcement, right? It's a BGP announcement which contradict one of these actually kind of incorrect ROAs, like France Telecom. So if you get these BGP announcements, that means that the entire ASPS does not enforce ROV, okay? So that's what we checked, and we could learn by this some ASs that do not appear, that are most likely, almost sure, do not deploy ROV. And that gave us, that at least 80 of the top 100 ISPs do not enforce ROV, which is pretty bad. As you will see in a moment, it's actually for deployment, for the value of RPKI, it's very bad. Is reality like this, or can we measure more precisely to make sure if this is correct, incorrect? Maybe it is, reality is better, or maybe reality is even worse. So we did some work on better ROV measurements. Actually, Thomas here, which is sitting over there, I can kill you someone. Okay, so Thomas, which is just a guy going blind now, also Randy, I guess. So he's been doing these measurements, and the basic result, I don't have time to go over it, we did use 3 different measurement methods and so on. The basic answer, we are still doing some of these experiments, but the basic answer is only a handful, like on one hand or at most 2 hands, domains or providers enforce ROV. So this is almost non-existent, okay, in real life, which is not surprising if you consider the result. If you do it, you will lose about 10% of the traffic of the domains which are doing the ROAS will be mistakes. You will be losing some significant amount of traffic. And Randy and quite a few others have done also some similar measurements. I believe, from what I understood, they have pretty similar results, but we didn't see yet complete details, so we have to see exactly. But probably it seems like the results are very similar. So, okay, so deployment is very, very limited, extremely limited. What is the impact of this partial deployment of ROV? Maybe if we have 1% deployment, we still get 1% benefit, or maybe more. Maybe if we have 5%, we'll get 5% benefit, or even more, and so on. So that's the question, right? What is the impact? So before I present the actual result, let me explain why essentially situation is bad. That is, if we have 1% deployment, we are expecting to have less than 1% benefit. And the basic reason is collateral damage, what we call it. That is, look at this example. Okay, and domain 3 is in green, or AS3 is in green, because he is actually deploying ROV. So that's a good domain. But domain 2 is not deploying. Now, here is our attacker, and here is the good guy, okay? What they do, they both announce 111 prefix, 111/24. Actually, the good domain is announcing 110016, which is a super prefix. But the attacker, of course, is doing a sub-prefix attack because this is the most effective attack. What is happening now is the fact that domain 3 has adopted our ROV does not help the traffic, because the traffic will still be sent to the attacker. The traffic to the sub-prefix is still sent to the attacker because of the sub-prefix attack. Therefore, namely, although domain 3, RPKI does solve the sub-prefix attack, don't misunderstand me. However, here it does not, because we have here a domain on the way which does not enforce, and therefore when the traffic reaches domain 2, as it would actually be misrouted and sent to the attacker. So the attack still works, although domain 3 is adopting ROV. Okay, so now we have to check, when does it happen and so on. We did simulations in the standard technique, which is very problematic. I know, I agree. Don't tell me it's problematic, it is. But that's the technique so far known. It's important to find a better technique, yes, but this is not our topic. So we use the CADA internet topology mapping of the different domains, the S's, and the relationship and so on. We pick at random a victim domain and an attacking domain. The victim domain, of course, is assumed to publish a ROA, and then we are checking we are selecting randomly which domains by the percentage that we are testing at that time are doing ROV randomly, and then we are just computing which domains will actually send to the victim and which domains will send to the attacker. That is the percentage, the success rate for the attack. What are the results? Okay, results are essentially that if you have almost all the network, actually here, the green one, if almost all the network is adopting, and here are just the 100 top ISPs, and we are seeing which of them are adopting, we see that as long as only a few of them are adopting, then the attack actually succeeds. Even if all the rest of the network is adopting except the 100 top ISPs, we are still losing, essentially always. This is exactly because of the phenomena I described earlier, okay? And only if all of them are adopting, then we get, to something like 20-something%, which is, that's the best that RPKI can get to, okay? But again, if a lot of them, if the top 100 are not, the fact that all the rest of the internet are adopting does not help us. Remember, we are not anywhere close to this. Now let's look at the reverse situation. Suppose that we convince all the 100 top ASs to, suppose that the rest of the internet does not adopt. What happens if all the 100 adopt? You see, it doesn't matter much. Okay, it does matter a little bit, but you see, if all the top 100 adopt, but the others don't, then we are also doomed. Therefore, ROV does require very significant adoption in order to be meaningful. It does not mean that it's not going to help us, but we do need significant adoption. Okay, so we must work on adoption if we want to get anywhere. Adoption here, as in many other internet standards, and definitely in many security standards, is a huge problem, and we should really work very strongly to do it. So these are our suggestions how we can try to improve deployment. First is raw alert. So actually I'll talk about these quickly, these mechanisms. These are raw alert, which is a mechanism to identify incorrect ROAs, and if you didn't try it yet, I recommend you do. You can enter it, you can try your own network, you can try whatever network you like, by domain name or by IP address, and you can see who are protected, who are not protected, who are issuing ROAs, and which of them are correct, which are incorrect, of course. Okay, and then we are developing the smart validator, which I'll talk about, and maybe a demo, and if we'll not have time for the, actually not real demo, but video for the sake of time, but if we'll not have time even for that, or if you just want to see more details, come to us, we can show you the real life demo, you can play with it, it's very nice. And of course, talk with us if you're interested in experimentation and deployment. Okay, so first, raw alert. Raw alert is a simple website and web service which is identifying these incorrect, wrong ROAs. And then when we do identify them, we actually try actively, reactively, in fact, or proactively, well, anyway, we send emails to all the operators that we can identify. Currently, we are not doing the best job of identifying the operators. We should improve on that, actually. But of the ones that we did locate and were able to contact them, about 40% actually fixed the error. So we actually conclude from that a very simple thing. If a serious organization, like RIPE, etc., will take this very simple work of raw alert and will actually do it officially, then probably we'll get even higher percentage rate and will improve significantly, reduce the error rates. It is a very simple thing to do. So that's one thing, and this should help a lot also to the ROV deployment, because it seems that indeed this risk of blocking a valid ROA is probably one of the biggest reasons for people not to deploy ROV. Okay, but then we are coming, okay, supposing or even that we do it and we still get percentage, maybe will be a bit lower, but will still be significant. How can we fix the situation from the ROV perspective, from the validation perspective? And then we are developing the smart or the learning validator. And we are planning now experimentation with Cisco, with LinkedIn, with a few others. And of course, whoever of you is interested, I would love to talk with you, or we will love to talk with you about doing more of this. Okay, so what is this smart validator doing? It has three modes, essentially. The first one is manual and learning mode. So it's together it's a manual mode allowing the operator to define exceptions to the regular ROVs. This ROV ignore, this ROV apply, and so on. And learning at the same time. What is it learning? It's trying to identify these incorrect ROAs. And when the operator so wishes, it can move to one of the two conservative modes. And the conservative modes are the ignore mode. The ignore modes means that the validator simply completely ignores all these incorrect ROAs. So for example, when I say incorrect, I mean stuff like France Telecom, where they may argue that the ROA is correct because this is the prefix. However, notice that if we adopt it, then the customers, which have been announcing for years, the prefixes will become invalid. So that's what we define as an incorrect one. We can argue about that, I agree, but from the point of view of deploying the system, it is not desirable. Okay, maybe let's not call it incorrect if you don't like it, but it's problematic for deployment, okay? And therefore, we will the first mode simply completely ignores them. The second mode, the second conservative mode, is an auto-extend mode, which means it is adding as if we had ROVs for these long-lived, announcements which are within these ROAs. That is, we kind of automatically fix, in a sense, or corrupt, if you like, let's say, France Telecom example. So we are issuing the ROA that Danone should have issued, so that they will not be, their announcement will not be blocked, okay? And that will allow people to begin to deploy ROV, and probably when that happens, then Danone will also soon fix their ROA. Okay. And there are two other ideas that we didn't actually yet implement. We are still more, the ROV++ is a mechanism to reduce the collateral damage. It gives incentive to deployment, but that's a long story and it's still in research level. And the pattern validation is a mechanism to give more benefit to RPKI by handling additional attacks. Essentially, some of the attacks that are currently only handled by BGP-SEC completely, and a lot of them will actually be prevented by employing the PET. And it was in this paper. This was in the SIGCOM conference of last year presented, and we will probably incorporate it within the smart validator soon. Okay, and I'll have to give details of that, but of course I don't have time for that. So just to explain a bit this logic of actually permitting BGP announcement, even if they are contradicting with a ROA, but they have been published for a few weeks and so on. If we look at the passive hijacking as reported by BGP Stream, you see that almost all of them have been within 2 weeks or less. So if you go farther than that, you only get a very small percentage of the attacks. Why is that? That's a good question, but I think I'm sure that each of you can understand some of the very good reasons for that. But the bottom line is very simple. Reality is that most of the hijacking occurs for very short periods. Therefore, by adopting this very simple rule, at least for the initial deployment of the system, we will actually not lose so much in its effectiveness. We will lose a bit. We'll have more false negatives, yes. Some attacks will escape the system, but not much, really very, very few. Okay, so that's the logic of the system. This is the architecture of the system. Well, I'll not go over it. It's pretty straightforward. It's going back. This is some of our dashboard of the system, showing essentially what I want to show here is the dashboard before when I am in the manual mode, not in the conservative mode. And here I present one of the two after we move to the auto-extend conservative mode. And you see this yellow thing. It's yellow, but this is actually the incorrect or the problematic ROAs which cause dropping of many legitimate BGP announcements. Legitimate in the sense they've been there and they are for legitimate customers and so on. They are contradicting the ROAs, of course. And here you see they essentially have disappeared because we applied this conservative mechanism. Okay, and now do we have time or not? 1 minute. You want to do a demo in 1 minute? Okay, so yes, so Yafim will try to do the demo in 1 minute. We'll see how that will go. How do I do it actually? I think you need to click on the link. Click on the link. Yeah, click on it. Link, yeah, click on it. No, just click on it. I think click on it. No.
In the presentation.
That's all.
5.
Yeah, that should work too. Yeah, go ahead. Huh? No, what's it mean? No, because it's into F5. F5. Oh, listening to me.
Yeah, I guess we will.
Man. Oh, there we go.
No, מתייחס לזה מצגת.
Okay, so we already wasted the minutes that we are supposed to have. So
You get a minute.
Okay, but that won't work, obviously. Okay, so please come to us later to see the demo. So I'm going to, oh, what's going on here now? No, it is not linked.
Just bring it back.
No. Yeah, I don't want to waste the group's time. So what are you doing?
Trying to unmute.
Well, oh, you are on. Now you're at
No.
least on there, right?
Windows.
It's not Windows. Oh, it is Windows, yes.
Great.
Yeah, I'm sorry, that's what the university provides.
Okay. Okay, go.
No, you don't see anything. So let's just give up on that because we already wasted time. But okay, thank you very much. I see there are some questions, better use of the time, I think. Okay.
Anthony Lambert, thanks a lot for this very interesting presentation first. I just wanted to come back on the beginning of the presentation. You say there is 10% persistently wrong arrays, and you give France Telecom as an example. I just wanted to focus on that point. People most of the time believe that hijacks are just bad guys stealing the internet. Actually, it can also happen. I don't say this is the very case here, but it can happen that some not delicate customers just leave with their IP block. So for instance, in this very case, it could be, Danone, the yogurt manufacturer, living with these IP blocks, which was first allocated by France Telecom to some other ISP. And then it becomes really complicated for an ISP to get the block back because, for instance, the customer can be also a customer for some other services. So, it's quite, I think, hijack, it's announcing legitimately some prefix, but I think there is much more situations than just people stealing the internet. And this could help explaining why there is persistently wrong arrays, maybe.
Well, if you want to talk about the specific example, the Danone are customers of France Telecom. It's not like they are not.
No, I mean, it's a customer, but it has been allocated some prefix at some time. It's still announced it.
Yeah, that's
but
fine.
It does not mean it's still allocated to it.
No, it is allocated. We've talked with them. The only problem is they did not issue the ROR. You see, if they need to be.
I know. I clearly understand. I don't say this is the point here, but I say that from time to time, some not delicate customer can live with a block. So actually, the area seem wrong because of max length prefix, but actually it's right.
Yeah, what you're saying is, and I completely agree, that in the current situation where we don't have RPKIs, then customers could kind of walk away with the prefix and nobody noticed and so, and we have a mess. And this does happen currently on the internet. Yeah, but I think this is a bit orthogonal to the whole issue that I'm discussing. I completely agree that current situation without, proper mechanisms like RPKI allow this mess to happen, and we are now trying to clean up the internet.
Yeah.
I completely agree with you.
Yeah, and I was meaning that can help explaining why so much wrong arrays persist. Because these are stable, wrong situation. People, it's hard for them to fix, actually. It's not just about some people making wrong configuration.
It's not the only example. We believe that most of these problems are similar to what we've shown in France Telecom case, in the sense somebody announcing a super prefix, and within it there are a lot of sub prefixes which have not yet been announced for us. Thank you. Okay, thank you.
Hey, just before we go too far down the line, we are short on time, so please keep it quick.
I'll try. Tim Reizels, Right NCC. So on the raw alert, we actually found that when we deployed a couple of years ago, initially the quality was much, much worse. And we've adopted something similar in our interface. So it's opt-in. Maybe we should look into making that a little more strong. But anyway, people can leave their email address and they'll be notified about anything invalid and unknowns. That's helped improve the data quality. Also, my colleague Alex Bond has been contacting people quite assertively, let's say, in the beginning. And definitely he did get the answer back at times that more specific announcements were actually unwanted. So that does exist. What was my last point? I had one more point, but it slipped my mind.
Well, I would love to, if you can touch later, so you give me, because I didn't write them down, okay? Please, thank you.
Rüdiger Volk, Deutsche Telekom. The point I would like to make is for successful deployment, we need, well, okay, there is actually a large space where additional tools and monitoring services are required. And well, the question whether we have the full tooling available by definition or by implementation or deployment, I would like to come back to the example from our French colleague, Anthony. My dumb question would be, well, assuming that one of your customers with delegated address space, actually you would agree that yes, that delegation should work. Do you have the tooling available in your current RPKI deployment that would allow that customer to get the delegation and then maintain their ROA? Or do you have the mechanism and the processes in place that allows your support to continually update what the customer needs? Yeah, kind of the current model of using RPKI is essentially a single level hosted service. There are very few exceptions, but we are, as far as I can tell, in no way in a situation that the large players would be prepared to really start to do their own CAs and do the delegation further down, while on the other hand, at the top level, interesting things are played and they don't even get onto the agenda of this meeting.
Well, I don't know if this was the question to me.
Well, sorry, sometimes I get to something and I don't even make the try to create the illusion of asking a question, rather to comment. The question certainly will be, well, okay, when do we find a time slot for actually looking at some of the details that are missing?
But you're looking at the wrong person, you know, if you're talking about time slots, I'm not giving time. So anyway, the comment was very interesting, so thank you.
So, guys, this is an interesting conversation. We should probably take it on the mailing list in an interest of time. We're running behind.
I just want to make a very quick comment that if the customer gets, let's say the customer would have not created the ROA, the ISP would have forwarded the traffic. So if the customer now announces a ROA, then the ROA gets maybe, or the route gets not injected, but the traffic still goes to the ISP, and the ISP still would forward the traffic to the customer. So I don't think that you wouldn't be able to order your cheese. You still would do it. There's just a problem with the ROAs.
No need to answer, but I wonder if in 10% of errors, you take into account more specific ROAS. I mean, if you would really lose traffic, if you were to discard this error ROAS. We can take this conversation.
Oh, okay, yeah.
Thank you.
That's an important question, but yeah, we don't have time.
Thanks. I think it might, no, it's yours, yeah. Yeah.
Okay, thank you very much.
Right. Jordy? All right. Stay in the box. You just say click. We have a thingy. We can do this. Here. So we're just going to the side.
I will present. Oops.
Why don't you pick it up? Take it off the stand. Take it off the stand. Take the mic off the stand. There you go.
Hi, everyone. So I will present how blockchain can be used to secure the location of IP addresses and its prefixes. First, I will make a short introduction to the blockchain, and then I will explain the use in this context. We would like to remark that this is not a substitute to the RPKI, it's just a preliminary analysis of how it might look like using the blockchain. So we are just seeking feedback from the group. So first of all, a short blockchain tutorial for those who are not familiar with it. In short, the blockchain is a decentralized, secure, and trustless database. It can also be seen as a token tracking system to know who has what. It is built adding blocks of data one after another, and data is protected by two mechanisms: chain of signatures, which ensures the ownership of the tokens, and a consensus algorithm, which ensures that data integrity. The first blockchain ever built was Bitcoin, which is used to exchange money, and this exchange is between two parties and it doesn't require an intermediary. But other applications are possible thanks to its properties. This figure shows the blockchain workflow. The basic unit of a blockchain are transactions. They have three elements: data, signature, and the public key associated with this signature. Transactions are broadcasted to a peer-to-peer network, and at some fixed intervals in time, one of the nodes in the network collects all transactions into a block. It then calculates the consensus algorithm, which means enforcing a set of rules agreed among all nodes, and then it broadcasts this block back to the network. When the rest of the nodes receive this new block, they verify the consensus algorithm and the signatures, and if they are correct, they add it to the blockchain. Since blocks of data are added one after another, it is called a blockchain. So this design provides several interesting properties. Among them, we remark the following. It is decentralized because all nodes have the entire blockchain, which makes it resilient. No prior trust is required. It decouples ownership from identity, so because data is only linked to a public key. It's append-only, so data can only be added but never modified, and it's verifiable because we have a history of all the transactions and we can check if a party performs an illegal operation. So a few words about the chain of signatures. So all the transactions are identified by a hash of the public key of the current holder of the token. When this current holder wants to transfer tokens to another party, it adds a new transaction signing the data with its public key. It should also be noted that the consensus algorithm does not allow signing several times the same public key because you would be giving the same token to several entities, and this is not possible. It is usually known in Bitcoin as double spending. So also a few words about the consensus algorithm. The consensus algorithm is the central part of any blockchain because it controls the addition of blocks. So it basically defines what is consensus and provides the nodes a set of rules which help them reach consensus regarding the state of the blockchain. The two most common consensus algorithms are proof of work, which is the one used by Bitcoin, and proof of stake, which Ethereum is planning a switch to it in a year time. So proof of work in one slide. Proof of work is related to computational power. And to add the block, nodes have to perform a large amount of calculations. For example, in Bitcoin, the hash of the block has to start with a fixed amount of zeros. This is quite hard because the only known way to do this is by brute force. But it also means that if someone wants to change data, it has to redo the proof of work. So this setup makes that if we want to modify the blockchain, maybe changing the last block would be quite easy, but the more blocks we go back, the harder it gets. On the other side, proof of stake takes a different approach. In proof of stake, all participants can add a block, but we take into account the number of tokens they have. So this way, users with more tokens are more likely to be selected to sign a new block. This way, this setup helps the blockchain in the sense that the users who use it most are the ones who maintain it. So they have a reduced incentive to try to cheat when they add the block. So proof of stake algorithm works more or less like this. To select the signer of block number 7, we make a list of all the tokens and their holders, and we randomly select one of them. The selection takes into account the number of tokens that each one has, and we can easily add a new block. So in this slide, we would like to summarize the features that blockchain has compared to traditional PKI systems. Regarding the advantages, it is decentralized, so there is no hierarchy. No certification authorities are needed, which makes management more simple, and also rekeying is very simple. It only requires a limited amount of prior trust, and it's auditable because we can always go back in the history of the blockchain to see previous transactions. It's also censorship resistant because data cannot be modified. Of course, it has some drawbacks also, the most important one being that it doesn't provide cryptographic guarantees like PKI. Rather, it hopes that the participants of the blockchain will behave good. It also requires larger storage because we have to store the entire blockchain. And bootstrapping is also costly because you have to download the entire blockchain. So now I will explain how we could use it to store IP address locations. We want to store a block of IP addresses and its holder, the chain of allocations and delegations of IP addresses, and the binding of these blocks of addresses to AES numbers. So why blockchain? We can see IP addresses as coins. They share similar properties. They are unique, so two parties cannot hold the same block of addresses. These blocks of addresses can be transferred to another party, and they are divisible because I can split a block of addresses and allocate each chunk to a different entity. So you could see a blockchain to exchange blocks of addresses. Just in Bitcoin, you send money to people. So if we want to build a blockchain, the first question that comes into mind is which consensus algorithm should we use? The typical choice is proof of work. It's the one that most blockchains use. But in our scenario, it presents some drawbacks. The first of all being that the parties that are blocks do not necessarily use the blockchain. So that means that in some cases, they would not be interested in its correct operation. In addition, if a party can hold enough computing power, it could rewrite the blockchain or select which data gets added. It also, in some cases, it's necessary to buy a special hardware to perform these computations. And these computations are also very inefficient because you have to do a lot of them. Here you can see a photo of this special hardware that you can buy if you are interested in mining Bitcoins. But on the other hand, proof of stake appears to be more suitable for this scenario. It doesn't require special hardware or expensive computations. But the key point is that the parties that control the blockchain aren't the ones that have more computational power, but rather the ones with more IP addresses. So in other words, the people who use the blockchain maintain it. So we think that proof of stake is more suitable for the IP address scenario because if a party was to perform a takeover, it would have to accumulate a large amount of blocks of IP addresses, so it would gain the right to sign a large proportion of IP blocks, of new blocks. But this doesn't seem very feasible because it means that an attacker would have to some sort of buy blocks of addresses to its legitimate holders in some sort of black market. And we believe that IP holders are not really interested in doing this because, well, they would gain some money, but they would lose their IP addresses and they would be compromising the security of the blockchain. So because of this, we think that blockchain, a proof of stake is a good candidate for a consensus algorithm in this context. So I will end up with a small example of how this might work. So first of all, IANA would allocate all the prefixes to itself, and then it would start allocating prefixes to, for example, the rears. Here we're giving 1/8 to APNIC. And in turn, the rears would allocate them to ISPs, for example. Here we give 1.2/16. And finally, ISPs would bind the address blocks to the AES numbers. This way, anyone can download the blockchain and, for example, check which AES number is linked to a block of addresses. And of course, we can always go back through the entire blockchain to see if this prefix was owned by IANA. And just to finish, our use case is Lisp. For those who don't know it, Lisp has a thing called mappings that are bindings of IP addresses to IP addresses. And it has a system called Delegated Database Tree, which is DDT, which is composed of several nodes that help you find these mappings. And we are building a prototype using a blockchain that would store all this information inside the blockchain. So it would make management much more easier because you don't have this hierarchical infrastructure. You only have these several blockchain nodes. And that's all. Thanks for listening. There are any questions?
Job Snyder's NTT Communications. This is very interesting material, and I get that blockchain technology is hip and some might call it sexy, but I fail to understand what problem are you solving?
So I would like to store the blocks of IP addresses in the blockchain and its holders and give a way to exchange these blocks between the holders.
But what is wrong with the current mechanism?
Oh, well, this is just a preliminary analysis. It's another way to do it, but. Well, the chairs, they said they could present.
So, George Michelson, APNIC, you may need to give a more explicit statement of what happens if somebody loses their private key. Because in most of the current implementations of blockchains, losing the key functionally destroys the value inherent in that component of the chain. It is impossible to recover without some process which functionally reasserts the hierarchy. You said on the slide rekeying, but that generally means consciously rekeying by signing over. If you lose your private key in most of the chains that I have seen, you have irrevocably lost control of the information associated with it.
Yeah, I agree that if you lose your private key, you lose so you wouldn't lose your addresses, but they would be always stored there.
But you are unable to functionally assert any statement about your addresses using the blockchain.
The transaction is still there, so the data is still associated with this key, but you cannot move it. That's true, but it's also possible to add some special mechanisms like requiring 3 or 5 signatures.
Sure, you could do M of N, but I'm saying if you are going to carry this work forward, you will have to address that issue because operation is an observed behavior. So the second thing is that one of your slides talked about the concept of public verification. And there is a concept in the general sense, which is public ledger. The sense that what you do is perform transactional change in a way that other people can observe the nature of your transactions, and that can include cryptographic proofs. That concept, public ledger, that's actually a really interesting concept, but the important observation I feel I want to make is it is not inherently tied to the blockchain. It is a thing, a concept in itself. And so if some of us are critiquing blockchains, in no sense are we necessarily rejecting transactional logs, public ledger and audit. They are high value. The problem is both proof of work and proof of stake as models of the computational effort or the evidence of participation have issues. When you apply them in the financial domain, and the use of blockchain that predominantly we see falls into 2 models. One of them I'm going to call Ponzi schemes, and I'm not really interested in that. It is the use of a blockchain-based coinage mechanism to declare a fiat currency and achieve massive value. And the other model, the Ethereum model, includes the concept of a contract, a digitally encoded transaction which is determined in time and sequence because of the encoding of that contract nature in what you are doing. And that has some interest because it goes to aspects of the public ledger behavior. But Ethereum itself has had some severe information crises. They have had people use faults in that contract to achieve distortions of the value inherent in Ethereum. And it's quite a difficult problem to specify what a valid Ethereum contract should be. That is a mathematical expression of something that is hard to get right.
Well, but I think this group knows very well how IP addresses and its blocks are allocated and they are exchanged among people. So I don't believe this is an issue. It's more of an implementation issue.
I think it is a very, very big issue.
Hi, this is Albert. I'm a co-author of the draft. I would like to give a complementary answer to Job. So the first thing is that we are not claiming that this is better than RPKI. This is what Jordi said at the very beginning of the presentation. We plan to do this for Lisp, and we were seeking feedback from you, the experts, because you know very well how to protect IP delegations. One of the main advantages of public ledger technologies, if you don't want to use the word blockchain, is that you don't have CAs, and you don't have all these management issues. If you consider that an advantage, that's an advantage. Then regarding the rekeying, it's true. If you lose your private key, you don't have any capacity to change your allocations or to do anything with your addresses. Now, the advantage is that it's only you that you can lose your private key. You don't depend on any CA. You are only responsible from your private key. No one else can screw it up, which I think it's a good advantage, right? And then you can rekey whenever you want. And lastly, I think that the presentation could have, I think that's the semantics. We could call it public ledger, and it's precisely the same as we are explaining.
Oh,
Rajiv,
okay.
sorry.
Very short,
Yep.
super quick. And we're done with the
This is very
line.
useful. I'd certainly appreciate this work. 2 quick points. Oh, Rajiv, sorry. Thanks to the chair, got cut off. So one, this would be useful to do the route validation, the origin validation rather, but not the path validation. So the question I had, whether there's any plan that you intend to have to also address path validation. Advertisement go from hop to hop to hop. Not so much the prefixes are getting transferred from one holder to another holder, but the same holder advertising the prefixes, like how it works on the internet. Validating the path would be very useful. So that would be one. Second, it would be also useful to see how much time and resources does each proof of work takes.
Sorry?
Proof of work, POW. If you look at the current set of algorithms, despite all the optimizations that have gone into from Bitcoin into the blockchain, whether you look at Ethereum or not, the time it takes to construct number of transactions and validate them, that's in seconds. So applying this technology into routing is certainly useful, but would be good to characterize how long does it take for every transaction that a number of transactions go in a block, how long does it take? So those are my 2 quick comments.
So the second comment, it depends on how you design the blockchain, because for example, in Bitcoin, it takes about 10 minutes to get data added, but depends on how you configure it.
Yes, a number of transactions going into a block and what's in the transaction and how it's signed. So more data would be definitely helpful. Thank you.
Well, I didn't have time to add all of this data.
Brian Wise, Cisco, just a couple comments. You don't have to reply to them. Thanks for your clear presentation. With the proof of stake, you mentioned that your attacker is basically somebody who can acquire or accumulate a large number of IP blocks. And I would just point out that in the structure, there are some of those attackers, of course. It's the registries at the top. We don't think of them as attackers, but they in fact have the ability of being attackers. And even worse is what people were talking about with the protection of the private key. Getting their private key instantly makes them an attacker, even if they weren't an attacker. So that would be important to think through. Also, I would point out that means that the control of the entire address allocation is, of course, still in the control of the same people that it is with RPKI today. So you might want to compare, if you're thinking about this for the address registry as opposed to Lisp DDT, how that would be different or better.
Thank you.
Randy Bush, IJ. The registries are about to each announce 0/0, speaking of attackers.
Okay.
All right.
Thank you.
Thank you very much. Tim, I think you have 3 in a row.
All right. I'll try to be quick without talking too fast. That's a challenge. So first, trust anchor locators. This is a mechanism used in the RPKI by relying parties to find the most recent root certificate that they have configured. And the way it works is you have some URIs listed there where you might find a certificate, and you have a fingerprint. So if you get the certificate, you can compare that it matches that. So next slide, please. Where I'd like to go in the future is ultimately remove the dependency on rsync. Maybe step by step, but a first step could be to allow HTTPS in addition to rsync. Next one. Or you could even go further and say, well, if HTTPS is easy enough to support on both the publishing and validating side, you might as well skip it and say, let's just say HTTPS only. Next slide. That does bring a potential can of worms into the room. We've talked about this in the Delta Protocol document. With TLS certificate validation, you could find that, yeah, there's so many CAs out there. You could think something is a valid certificate, although maybe it shouldn't be. You could also find that people have made configuration errors or stuff with ciphers and what have you that can be misconfigured. And well, essentially the TAL already contains a subject public key info field. So essentially, even if you got the file from a possibly untrusted source, you can still verify that it matches. So we probably need some text here that would allow you to maybe warn but ignore most of these problems. Next slide, please. So to wrap it up, I believe this is the last slide at least. My preference would be to move forward quite assertively here, actually, because I think it's trivial for CAs to publish certificates under an HTTPS URI rather than rsync. And I think it's easier to scale it that way anyway. Also, I do believe that for relying parties, if you support getting HTTPS as an optional addition, it's also, you know, it's actually easier if we can remove the need for rsync, because it gets us one step closer to not being dependent on an external tool. Then discussion, I don't think we need to have that all here right now, but you could have strategies. What if you have multiple URIs there and some of them have warnings, others don't? Probably something to talk about. Next slide, please. Yes, there was one more. So basically that gets me to this one. Again, I'm trying to slowly get to the point where we don't need to run rsync servers anymore, and I don't need to call rsync from a relying party tool. This is I think a useful first step to get there. So first question would be, and I guess that needs to go to the list, but is the working group interested in taking this as an item and discuss further? Then there are currently 6 mentions for rsync, and there's HTTPS validation considerations. So I think probably a obsoleting 7730 rather than doing a in-place update is easier or will make the thing more readable. And then if we're all good with all this, then are the current authors of 7730 interested in following up, or if needed, I can also take up a pen, but no, start writing. So that's it, really. Questions, comments?
I could be a little confused. I'm perfectly happy to get rid of rsync as long as we have a plan and migrates well. But given the RDP fetches, don't I get the address of the certificate at the root that I can compare to the hash in the TAL? What better verification is there?
So initially, the RDP URI is included in the certificate, but you first need to get it. So when you first bootstrap, you don't have it. You would have to do an rsync fetch first. Then potentially you could find a root certificate that says, has a notification XML in there that includes the root certificate itself that you may want to use in future somehow, but that's, I think, a bit poorly defined. So in a nutshell, no, I don't think RDP gets you there. You could have a URI here that is similar to a RDP. Maybe that's what you meant and I misunderstood. So you could point to a notification file of the Delta protocol and then look at all the files included there and then find the one that matches the key. That could theoretically work, but I'm not sure that that would be better. I think it would create more uncertainty and smartness in the relying party that might break.
The trust model of HTTP is another whole world. And then I'm going to want to, of course, put Dane on it. And then, so, pardon? Trust semantic, right.
Rob Ostine, DRL. I agree with Tim. I don't think that RDP replaces the need for this. I think Tim is on essentially the right track here. We can talk about details, but I don't think RDP replaces the need for something for the TAL fetch. Tim, I know, is aware as one of the co-authors of RDP, but I want to be careful about how we handle TLS HTTPS validation failures. I think we essentially want to handle it the same ways we did in RDP. It's good to try to do the HTTPS validation, but I'm not sure that RPKI should come to a screeching halt if somebody screws up their HTTP server TLS validation. So it's essentially the same kind of thing about failing over to insecure because the data themselves are secure via another path.
Job Snyder's NTT. I do think it's useful to standardize on a transport mechanism within the whole tool chain, and HTTPS might as well be the one standard. If you're gonna work a little bit on the TAL locator file format, perhaps consider changing it to JSON and perhaps adding a version number so that the next time we add anonymous SCP, it would be easier than forklifting this document. But that's just a very small suggestion.
I'm not sure that I should be the one to comment on this one.
Dima
I suggested
from
something similar earlier. Thank you.
Dima from ZDS. I really think this is an interesting idea, but I'm wondering whether the relying party software will benefit from this design. And is this design going to change the state machine of relying party software?
I think there are two benefits here. Even if you make it like an optional choice or, still allow rsync, but you don't have to use it. As a CA, I find it easier to scale because I can use a CDN, I can offload this as existing technology to make my certificate available. For the relying party, if the CA also chooses to use the Delta protocol, then a relying party tool would prefer that. So if we have HTTPS on the TAL and we have the Delta protocol as, again, still an optional additional thing, but if it's used, then for that particular part of the RPKI, I mean, it could change with dedicated children and all that. They might use different publication points, but essentially the relying party tool would not need to call rsync at all then. And I think that has performance benefits. It makes error reporting easier. And well, many more details that maybe we shouldn't talk about as lengthier. But
so you are suggesting the design could be totally optional.
So I think if we were to say you could use either, you choose. That gets me a long way there.
Okay, thank you.
Just so we're clear, you're going to email the mailing list and say, I'd like to do this thing. Is the working group interested? Please speak up.
can the chairs ask for working group adoption for the draft that's not yet written, right?
Yes.
Okay.
Yes. So I can repeat basically our last slide to the list and then move on.
Okay. I think
No?
that's the next slide.
Oh, yes. It is? Okay. Missed the title. So the next thing I wanted to talk about was basically what kind of related to the previous one. So if we change the URIs on a trust anchor locator, or what happens if I want to rekey? There is an existing deployment of relying parties out there who have their trust anchor locators installed locally, and I can't easily inform them about my desire to either publish my certificates in a different location, for example, using HTTPS, or I may actually want to do a rekey. So we have this issue, we use HSMs, and essentially we have a vendor lock-in at the moment. We can get new hardware of the same vendor and keep using the same key, but we can't very well go to another vendor. So this is an issue for us. And yes, moving forward. So I wrote a draft together with Carlos and put it out there. This is not by any means meant as a final solution, but it's meant as something concrete to look at and see if this will work, or alternatives I'm very open to. So, but there is a real problem there that I'd like to see addressed. Oh yeah, and importantly, what we specifically do not address is emergency rekeys. So what happens if I actually lose the root certificate key, or it's compromised? I don't have that problem at the moment, fortunately. I don't really know how to solve it either. It would be great if you could solve it, I suppose, but then again, I wouldn't want to stop solving other issues that I do have today by talking about that solution. So, moving on. In concept, it's really simple. What I would propose is that relying parties use a trust anchor locator. They can find a trust anchor certificate. There's a whole lot of things that are published by this certificate. Essentially, the document just says, well, let the trust anchor publish a new TEL as a signed object, as an RPKI signed object of a new type. And when the relying party finds that, basically instructed to replace the trust anchor locator that it had with this new one. That's essentially all there is to the idea. But then worked out for two different use cases. Yes, next slide, please. So for a key role, now here it's quite aggressive, actually, the timeline, but that's a point for discussion, as I mentioned earlier. First of all, you would have to prepare your new key, set it up in such a way that everything is there. Republish everything you were publishing on your old key, and then we can publish the trust anchor locator under the old key. So this can instruct relying parties to go to the new location, new key. Then a staging period seems reasonable. How long should it be? I don't know. 24 hours is kind of based on the, yeah,
the RFC 5011 problem in DNS for key roles at the root. I think there's some prior art there we might be able to reuse. I'm sure there are many, many ideas for how to make it even more complicated than 5011. But I think at the very minimum, we want to look at some of the timelines that are used in 5011, some of which are much longer than what Tim is talking about here, and some of which involve pre-publishing keys in order to allow you to do something. It's essentially a way of addressing the emergency key role problem, is to have the next key out there already, and then you can switch to it quickly if you have to. But yeah, we can discuss this.
Randy Bush, and we already have that elsewhere in the pre-publish. We also have elsewhere. I also just want to whine that the 24 smells somewhat like /64 in IPv6.
Yes, that was arbitrary, and I know.
Okay, next presentation. Just so we're all aware, you have time for the presentation to go? Yeah, you should definitely go. But we're going to run a little bit into the break.
Okay.
People can stay or leave.
Okay. Well, next slide then, please. I want to keep this one very short as well. The tree validation document is kind of misnamed, as I also raised on the working group mailing list, because it really describes what our application does. As such, yes, we can continue with the IETF process. Go for last call, publish it. Randy already expressed support for that, so that's great. Otherwise, we just publish it with our code. We say, thank you, IETF, but we are going for a more lightweight way of documenting this. I see some merit in A, but basically, I think we need a decision and move on. And that's all I had to say on that one, actually.
Randy, again, we have a long tradition in the IETF of publishing RFCs of Cisco's method of chewing gum or whatever. And this is just another case of that. This is how you do something. We want it documented. Ship it.
Rob Ostine, DRL. Yeah, this does not need to be a working group document. Just publish. This is what RPK, this is what RIPE did. It's useful as it is. Get it out the door. Speaking as an implementer who actually read the document while implementing some of this stuff, it is extremely useful, but it doesn't need the working group to fiddle with it. It's just, it's done.
Well, okay, given that it is a working group document, does that mean that we need to finish that process?
I think the suggestion, which we should have discussion on the list, but is just push the work for last call and push forward. I think if you have links to your code and whatnot in the document, then that whole rock process continue as you need to there. So,
all right, thank you.
Yeah, I'll send a note to the list for you for that one.
Okay.
Okay, and sorry, not you. Randy's next with his no slides, short 10 minutes or less.
In the interest of trying to get this sucker deployed, we have some problems with implementations of route origin validation in routers. Two, I would like to point out, and mea culpa, RFC 60 whatever, 6811, I think, clearly was not clear enough. There are two significant problems. One is when I make an announcement to Rudiger, no matter how I learned that route, if Rudiger's NOC has to call me and tell me that I have announced an invalid prefix, this is not good. My router should have validated it. When it learned it from eBGP, when it learned it from IBGP, when it learned it from IGP, when it learned it from a static, when it learned it from a fortune cookie in a cereal box. No matter what, when I put it in BGP, it should have been validated. Okay. The second problem is that we seem to be, well, no. The draft, the RFC says the operator is in control through configuration of what is done with a with a route once it is marked, not found, valid or invalid. I get to decide. I know the helpful fatherly vendors, excuse the sexism, will think they know what should happen. You don't. We have current implementations that not just mark the route, but drop invalids by default, create communities by default, etc. Stop. Just stop. I have Steve Bellevin, a security researcher, as a customer. He only wants me to give him invalid routes. Just stop doing gratuitous action. I have the ability to do it all in policy. So, two things are in the draft. One is, no matter how it got into BGP, mark it. Two is, don't do anything else. Well.
Hi, Randy.
Who are you?
Rüdiger Volk, Deutsche Telekom still. And yeah, all okay. I certainly agree. I note that, of course, we have to expect that not everybody is using this. And so, of course, I have to deal with the situation that some of my customers may not do the RPKI classification, and I still need to tell them that they are sending me junk, or some of my valued peers do the same. I would wonder whether adding to that draft a hint that the implementations actually should make it easy to produce the message for the neighbor who is sending invalids. Easy. There are currently some vendors where it is easy, and there are some vendors where it is really painful.
I'm sure Job has some hack with communities to send whatever to make it happen. Can I do it by policy?
Well, at least if I decide to drop the announcements, the vendors who have optimized their implementations by not storing and not keeping rip-in information, I have no way actually to do the messaging.
So if they've done what I'm telling them not to do, I should have some way to signal that? No, just don't do it. But I take your point that if I, by policy, decide to drop your route, maybe it would be nice if I could tell you. And now we're back to these sophisticated, to be kind, signaling mechanisms, which are not my forte. But I think we have some expertise sitting right there. Hi, Job. Kair.
Yeah. Kair Patel, Arcus. I just wanted to add that I think the last time I looked at RFC 6811, it doesn't mention rules for redistributed routes to say how you're going to do the origin AS validation, particularly for the ones that you originate on the router. So if you're going to ask working group to do this, maybe you probably want to issue a BIS on 6811 and expand those rules.
Kair beat me up about this out of band. He is correct, but let me rephrase it because it took a while to sink into my head and it may take a minute or two to sink into yours. If it comes from if I am originating this route and it's coming from my IGP, static, etc., connected, etc., then If the router is to validate it, it's got the prefix, but what's the AS number? My router might have multiple AS numbers. We have all sorts of things about that. We have confederations, we have AS shifting and transfer, et cetera, et cetera. So this does require more thought. Thank you for beating me up a second time, Care. Jeff.
Jeff Haas. So Randy, I think you want to go one step further and say you do not even want to mark these routes by default.
No, I do not want to go by that step.
It's what I would suggest, though.
Job Snijders, NTT. Would it be perhaps useful to recontextualize your draft as an update to 4271 to very clearly indicate at which step of the conceptual process the validation and marking takes place? Because if the issue is that implementers get it wrong, then maybe this could be a different way of pointing out that this is where things happen.
Thank you for sharing.
Anything else? No? Okay. Thank you very much. D. Ma, please. Declan.
Good afternoon, everybody. I'm Dima from ZDS. I'm one of the administrator of a sort of RPK Reliant Party software called RPSTR. I will be briefing this draft and responding to some comments from the mailing list since the inception of this work. By the way, this work was first introduced in CIDR meeting in Buenos Aires, and we also believe we also would like to move it on in Sidrops working group, and we believe this work is in alignment with the charter of the Sidrops in terms of RPK Reliant Party. Next slide. Moving along to the background, the fact is requirements imposed on RPs are scattered throughout many IFCs. So this makes it harder for an implementer to be confident that he or she has addressed all of these generalized requirements. So next slide. The fact is still that software engineering calls for how to segment the RP system into components. In addition, that you should be aware all of what the requirements are. So as such, these components could be distributed across the operational timeline of user. And granted, we also believe the taxonomy of generalized RP requirements is going to help. Next slide. Okay. Here comes the overview. Above all, the most important thing is to usher the reader to the right place where RP requirements are normatively defined. By doing so, it assigns the requirements that appear in several RPK documents. In some cases, it paraphrases the requirements, while in other cases, it may merely just restate them. Next slide. What would this document be like? We might well see this document from three perspectives. First, are we going to define the RP? No, we just do some pointing, ushering, and stuff. Some guys may inquire as to how this document could be kept up to date. As far as we get down to this work, this document has been focusing on the fundamental requirement imposed on RP, which, by the way, is basic and indispensable responsibilities for an RP to assume. So all the requirements described here in this document would be stable as long as the RPK is standardized the way we see today. So that's the reason why we don't make local trust anchor management as a requirement, because and we won't, because local transfer anchor management is kind of extended RP function. and won't make any difference in terms of the integrity of an RP system. So next slide. It's easy to figure out the outline of this document. We take a glance at the catalog of this document. As far as the RP are designed, the basic functionality of it could be divided into 4 categories. The first, fetching and caching the RPKI repository objects. Second, processing certificate and CIL. Next slide. And then processing RPKI repository sign objects. Well, by the way, I believe the design manifest is really a tricky part. So I hope maybe we could do some update of manifest design. Okay, the last but no less important one is delivering validated cache data into the BGP system. Next slide. In light of some feedbacks from the main list, I'm therefore feeling obliged to deliver a clear message here that, as I recall some concern from showed up in the main list. Are we suggesting that implementer should skip read those RFC4? No, anyone who wants to comprehend can't be exempted. Okay. Granted, this draft could be seen as a guidebook to some job of, to tell you the manifest all the requirements. Next slide. Okay. There were discussions on whether this draft is redundant to the existing working group item on tree validation. In our defense, I would like to take this opportunity to reiterate our point of view. The RPK tree validation document describes how the RIPE-NC validator software works, while this document is more generic. And the tree validation document is expressly a description of one particular RP implementation. Thus, it is an example of how that implementation tries to meet the RP requirements, not a general characterization of RP requirements. So I hope this document could be adopted as a working group item. So next slide. Okay. This photo is taken by my co-author Steve Kent from his Florida field trip last year. This bird is ready to answer a question.
I think we only have time for one question, Reuter, so make it quick, and then Oliver's up.
Okay. For the last paragraph you had up, I would repeat earlier comments that, well, okay, the relying party implementation requirements document that you are presenting here, well, okay, it actually could have one paragraph that says an implementation should come with a documentation, and Tim's document is doing that for his implementation. So that's very easy, and well, okay, actually putting in that should into this document, I think makes a little bit of sense, just to make clear that this is important. And the other thing is, yes, I would suggest really talking about relying party implementation, because I am a relying party as a person. And I won't function as a relying party implementation.
Thank you. In my defense, I think the tree validation from the RIPE-NC is for a specific implementation. But this document is help RP implementers to do some engineering, still with their choice. It's open. Okay. Thank you.
Okay, Oliver, you're up. D, please send a note to the list about your request for adoption.
Okay, I try to be quick. So at IETF 97, we gave a little interoperability demo, and I want just to give a little quick update about the reference implementation of BGPsec. Next slide. So we implemented full support for the RFC to be 8210, what is a 6810 bis 9, I think, at this point. We allow to receive router keys directly into the implementation. We also updated the BGPsec capability and BGPsec paths attributes to the IANA assigned values. This gives a little bit of a problem because BERT still, I think, has in the code the old values. Therefore, we allow even in the compilation to put the old values again for backwards compatibility. Next slide. Then for everybody who, there was a discussion what Rüdiger and I had many, many years ago, at I think 4 or 5 IETFs back. The problem with the time when the validation cache sends raw updates and you want to react right away on the changes with validation of your updates, depending how the RAWs come in, it might be that a RAW what was valid, an update that was valid now becomes invalid, and then the next one becomes valid, and that brings a real churn on the router, what is not necessary. So we change our implementation in such that we internally do this processing, but we notify the router after the end of data, so that we still might have a little bit of a churn, but because if a router asks during this update, it gets in between. But nevertheless, so we reduce the churn dramatically. Next slide. So then we created another tool that's called BGPsec.io, and this tool allows us, so what we need a BGP traffic generator that has more than one signed hop in there. So we wanted to be actually able to take MRT table dumps and generate BGPsec traffic, all of them. We just create our own keys and so forth and do these things. The other thing was, in our implementation, we took the whole crypto module out, and we wanted to have, for performance measurement, a tool that just calls validate, 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 or sign, 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 to have the whole other offset of policy processing and so forth taken out to just see how the performance of the crypto part does. Then on top of it, we wanted to have a little nice printing tool that gives us Wireshark capability of printing. And we wanted to generate, or we want to generate in the future, test vectors that can be stored and then replayed by someone who wants to test their own implementation. Next slide. So what we did in the BGPsec.io, it's a traffic generator that creates the fully signed BGPsec updates. It allows to store these updates in binary files. We wanted to have a very, very simple way of scripting updates. So the prefix alone would basically mean you originated. Then you can just look at this. It speaks for itself. Next slide. Then the crypto tester, we have, as I said, we have our crypto engine where we only need the BGPsec path attribute. We don't need the whole update with community strings and so forth. Where if you implement the crypto API and you create a plugin, you basically can test this plugin against lots of traffic as well. Next slide. And so there was also another thing. We wanted to have more than 2 reference implementation of BGPsec itself. So we forgot everything what we did, and we had someone differently implementing BGPsec to just make sure that what we do does the things right. And so then we came to the thing. The problem with ECTSA P256 is it's a non-deterministic algorithm. So you have problems with the signatures all the time different. So we went to RFC 6979, which provides some keys, and we allow to generate signatures using this key so that you can basically always get the same signature for the same, so like any other algorithm. And then we also implemented things, especially for testing. What happens if my update signing fails? For example, due to a corrupt key or a missing key. So we allow that if you have now an MRT file feeding in, and there might be that you miss a key, either you drop the whole update, or you fall back to an AS4 update, or we also allow to fake a signature and fake an SKI, where you say, you know what, I want to see how the other router reacts, even if I give them a real SKI, but now with a fake signature, that they don't say, hey, that is valid. So next slide. Wait, let me see. Yeah, and then we have the player. So when we generate all this stuff, we store it in BGP-sec traffic in a binary file. For the crypto tester, we also store the public keys. For BGP-sec traffic, you have to pre-install or load the keys or get them via the RC2B 8210. And you can play them. The good thing on this is, especially if you make BGP traffic, when we sign all these updates, we create, it's not highly performant. So we want to take all this crypto overhead and generation overhead taken out. We want to feed into the router as fast as possible. So that's why we allow them to read directly the binary file. So the only thing what we now have is IO time from reading the stuff and just putting it as it is on the wire and sending it to the router. Next slide. And that's our printer. In this printer, you can basically also use BGP-sec IO just as a sink. It doesn't produce any traffic. It keeps the session open and receives BGP-sec traffic. And then I can filter on everything. I can filter, show me only the update, show me the open, show me notifications, show me keep alive, whatever you feel like. And you can, as I said, you can have it on the receiving side. You also can have it on the sending side. So highly good for debugging. Next slide. And that's where you get it. Still BGP srx.antd.nis.gov. The source is open source. If you have any question, come to me. I'm here all week. I can answer questions. I can give small demo of this tool what we have, and that's it. Thank you.
Thank you. Thanks. I think that's it. Might still be cookies left. Good. Are the blue sheets in the back of the room? And if you didn't sign them, you should sign it, please. Just email something to the list so I don't forget. Hey.